This is Mr. Anderson for Kellogg Community College. We're going to be looking at the second part of Chapter 3, Section 2. We're actually going to look at some inverses of our secant, cosecant, and cotangent functions. Now I'm going to give to you some of the notes and present it to you in a table. This is going to be the name of our inverse. This is what it means when we switch our x and y around. And where is that possible, and what other restrictions we have on our inverse. So this is going to be the secant. The inverse of secant, it really means if you switch the x and y around, you change it to the secant function there, where the absolute value of x is greater than or equal to 1, and we are between 0 and pi. For our cosecant inverse, if we switch the x and y around, we get cosecant of y, where the absolute value of x is greater than or equal to 1, and we go between negative pi over 2 to pi over 2. Obviously, we can't include a couple values here. Y cannot be equal to pi over 2 because it's undefined, and likewise with y, 0 cannot be 0 for the cosecant. Now what's kind of nice though, if you think about cosecant as the reciprocal of, if you think of secant as the reciprocal of cosine, you can see where the boundaries are the same. So if you're trying to memorize some of this here, you can kind of use your previous memorized facts to kind of gel with this. Just make sure you don't include 0 and pi in that situation because of the inverse's graph. Cosecant, its reciprocal function is going to be sine, and sine also plays the boundaries in the first and fourth quadrant again. But this is the real wonky one here because this is the inverse of cotangent, and if you then switch this around, this gives you the cotangent of y. Like tangent, your x restrictions were all real numbers, so there weren't any x restrictions. But this is the real troubling one here, and it's troubling because this is not like tangent. This piece right here is more like cosine, and we're going to use that fact when we get down to the bottom for problems 19 through 24, when we have cosine or cotangent that are, since we're looking at only between 0 and pi, that's going to change things a little bit, so we're going to have to be kind of aware of that. Now if we go to our unit circle, we can easily find our values for theta, because we're going to try to find out where theta is. So theta would be where the cosine, so the cosine of, the cosine of theta is going to be at the square root of 3. And we can see that is going to be at the place of pi over 6. We also, you can rewrite this as the cosecant, or cotangent, sorry, whoa, the cotangent, I kept writing cosine there. The cotangent of theta, is equal to the square root of 3. That's where to find theta, we'd have to look at our unit circle and see where this is, and that would be at pi over 6. Inside of that boundary there that's labeled by the problem up above here. If we have to do this for the inverse of cosecant, we can go to the unit circle where we have the cosecant of theta is equal to square root of 2. Of course, we got to kind of follow our boundaries here, and so the answer would be pi over 4. This here is going to be looking where the secant, we want to find the secant, to find our theta, we're going to look on the unit circle where the secant is equal to -2. And again, using our bounds up above here, making sure we're only between 0 and pi, the answer is going to be at 2 pi 3. And our final one down here, there's a typo on this. I'm not sure it's been changed yet, but depending on your worksheet, that should be a 3 in the denominator. I'll get that fixed. And now we will take this back to the answer here, and we are going to find our theta, since this is equal to theta. To find our theta, we're going to look on the unit circle where cosecant theta is equal to negative 2 square root of 3 over 3, and that is going to be at negative square root of 3 because the cosecant has a restriction on the first and fourth quadrant there. So if we get to the calculator work, I'm actually going to take a couple of these problems out of order, and I'm going to do that because the cotangents are actually the real kind of weird ones here. So let me just put a star beside each cotangent problem because I want to actually do those kind of as a block. But if we are going to do the cosecant into the calculator, you don't actually have a cosecant on your calculator. But a way to do this then is to think about what was the reciprocal function of cosecant. And the reciprocal function of cosecant was sine. So in your calculator, we can type in the inverse sine of 1/5. And in doing so, that's going to give you your answer of 0.20 because we're rounding to 2 decimal places. So 0.20 or 20 hundredths or 2/10 is your answer for this problem. For secant, the reciprocal function of secant is cosine, and we can take the reciprocal of this to type this into our calculator. Here's negative 1/3, and this gives you 1 and 91 hundredths. And down here, just like in problem 20, we're going to take our cosine, inverse cosine, and we're going to take the reciprocal here. Here's negative 3/4. So that gives us an answer, and so we type that into our calculator, of 2.42, or 2 and 42 hundredths. Now what I'm about to do is I'm about to clear this out because I'd like to have a little bit more room for 20, 22, and 24. Because the problem with just taking the tangent, the inverse tangent, and then flipping this on its head is that the inverse tangent and the inverse cosine, or the inverse cotangent, do not share the same boundaries for where we are looking at the graph. In fact, if you look at just a tangent and cotangent graph, they have different asymptote lines, and that prevents us from doing that quick little trick that we did for the last 3 problems. So what we have to do, and this is going to be a little bit more of a process, is what we will do is we will look at where cotangent is on the graph. Now cotangent is adjacent over opposite. And that's important to know because we're either going to be in the first or second quadrant. Since this is a negative, this is going to be in the second quadrant. And what we'll do is we'll actually draw our triangle from the perspective of theta there, because if this is equal to theta, then we can say the cotangent of theta is equal to negative 1/2. Now, according to the perspective in the second quadrant here, with our right triangle, our x is going to be negative and our y is going to be positive. So the adjacent is going to be our negative 1, and our opposite is going to be 2. Now what we will do is use the Pythagorean theorem to find our missing hypotenuse h, because we're going to need that to actually get to our calculator-based answer. So we're going to type in negative 1 quantity squared plus 2 quantity squared is equal to h quantity squared. So this is going to give us 1 plus 4 equals h quantity squared, 5 is equal to h quantity squared, h is equal to square root of 5. So let's put that there. H is equal to square root of 5. Now, what this gives us now is our 3 parts of a triangle, and we must now seek out cosine, because cosine and the inverse of cosine and the inverse of cotangent share the same boundaries from 0 to pi. So what we'll do is, instead of taking the inverse of tangent for this problem, we're going to take the inverse of cosine for this problem. And according to my triangle right here, cosine, which is the adjacent over hypotenuse, is negative 1 over square root of 5. Now, what this means here is that we need to type this into a calculator, and I don't need to rationalize a denominator because this is just strictly inputting things into the calc, and that will give me my answer of 2 and 3 hundredths. We're going to repeat the same process. We just did problem 21 right here. So we're going to do problem 22, and it is also in the second quadrant. So we're going to have another right triangle with theta perspective, and I knew it was in the second quadrant because of the negative angle, or negative, negative symbol. Now what I'm going to do is put these in places because cotangent is adjacent over hypotenuse, so this is negative. This is actually, yep, negative 8.1 over 1, and we're going to have to find out h. Now, using our Pythagorean theorem, we have 1 squared plus negative 8.1 quantity squared is equal to h squared. And what this will give me is 66.61 is equal to h squared. So the square root of that, of 66.61 for h, gives me an approximate answer of 8.16, or 8 1600ths. So, like we did in the problem before it, and I think I'll put a little division in here so we don't get too far off there. What we did in the problem before it is we sought out cosine because of the similar 0 to pi restrictions. And the inverse of cosine was the only inverse sine, or like inverse sine and inverse tangent, did not have that restriction from 0 to pi. So that's why we have to choose this. And then we will type in our adjacent, negative 8.1, over our hypotenuse, which is 8.16, and then we get our answer of approximately 3 2/100ths. Now for problem number 24, I'm going to clear the screen out and do that one with you. Okay, problem 24, our last step, again, is in the second quadrant. I feel bad about having 3 problems in the second quadrant. This is negative square root of 10 and 1, because this is the adjacent over the opposite. So we're going to find out h, and we're going to have our setup, which is 1 squared plus negative square root of 10 quantity squared is equal to h squared. So 1 plus 10 equals h. Because the square of a negative is positive, the square root of 10 is 10. So we got 11 equals h squared, and then we take the square root of both sides to get h. Now we're going to seek out inverse cosine of our angle theta to figure out what our answer is. And since this is the square root of 11, the adjacent, in this case, the negative square root of 10 divided by square root of 11 gives us an answer, once we compute that, run that in there, of 2.84 hundredths. And that's when you type that in. You might say, well, should I have rationalized the denominator? And it's really not necessary, since we're just plugging that into the calculator to find the exact value. Or actually not, it's the approximated value. All right, well, thank you for watching, and if you have any questions, shoot me an email.